what if we're looking at two events and they're actually independent events, like coin tosses? The probability that a second toss of a coin is a head, given that the first was a head, comes out to be the same probability, 1 out of 2, as just tossing for a head. So independent events are independent if the probability that one happens given the other is the same as just the probability happening on its own. This means that the occurrence of one doesn't affect the other at all. So if both of those happen, so if we're looking for the probability of A and B, and they're independent, then we just take the probability of one times the probability of the other. They're not going to affect each other at all. This makes it even simpler. So let's say we roll a die and we toss a coin. Is rolling a die going to affect the coin toss? No. So what's the probability of getting a 4 and getting a head on the die? Well, probability of getting a 4 is 1 out of 6. And tossing that coin and getting head versus tail, that's 1 out of 2. So that's 1 out of 12. Just that simple. A bag containing 3 marbles, 3 red marbles, 4 white marbles, and 3 black marbles. Find the probability of getting a red marble on the first draw, a black marble on the second, and a white marble on the third, if the marbles drawn are drawn with replacement. The key word there is with replacement, so I'm putting it back in. So if I'm replacing them, the probability of drawing a red marble is 3 out of 10. Then I put that marble back in. So when I draw again, getting a black one would be 3 out of 10. And I put it back in. And so when I draw again, the probability of getting a white is 4 out of 10. So that's 36 out of 1,000. But look at the difference if we have the without replacement. So I don't put the marble back in. So when I draw the red marble on the first draw, there were 10 marbles. But on the second draw, I'm going for the black marble. There's 3 of them. But now that the total has gone down, then for the white marble there was 4 of them, but the total has gone down even further. Now it's an 8. So I get 36 out of, what is that, 720. Identity theft. Suppose a person learns the first 5 digits of your Social Security number. Calculate the probability that the person guesses the last 4 digits. So do the last 4 digits have anything to do with the first 5 digits? No, they don't. They have nothing to do with it. They're totally independent. So independent. So it doesn't affect it at all. So each of those digits is 1 out of 10 possibilities. Though knowing those first 5 will not affect the chances of figuring out the rest of them. 1, 2, 3, 10,000. Yeah. Oh, there. 4. I can count my zeros. Coin tossing. Find the probability that we're tossing a coin 4 times and that no heads appear. Well, that means it's the probability of getting tails, 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 and tails. Well, the probability of getting the first one is 1 out of 2. Probability of the next one is 1 out of 2. Probability of the next one is 1 out of 2. Probability of the next one is 1 out of 2. So it's 1 out of 16. Probability that at least 1 head is obtained. At least. So that really just means that's the opposite probability of at least one head is the opposite of not having any. Would be the same as 1 minus the probability of 0 heads. So it would be 1 minus what we found in the last one, which would be 15 out of 16.